quadratic equations and models. Module 8 was using factors to solve quadratic equations. We learned the 3 types of factoring. We learned the simple way of factoring when the leading coefficient is 1. We learned factoring by grouping when the leading coefficient wasn't 1. And then we learned difference of squares. Okay, that was Module 8. Module 9, we realized that we can't always factor to solve these quadratic equations. And when we can't factor, we have to use other methods. The first method we learned about was in lesson 9.1, and that was solving equations by taking square roots. Now, we're going to skip lesson 9.2, which is another way, and we're going to go directly into lesson 9.3. Why are we skipping 9.2? Because I believe just about everything that you will be required to do in your lives of mathematics can be done using the information gained in 9.3. Sorry, I said that the wrong way. Most of the things that you could do using this skill, you can also do with this skill. Does that make sense? So there's very little point of teaching you this when you can just learn this and not have to learn both different methods. Does that make sense to you guys? Okay. So the whole point is you can't always solve equations by factoring. You can't always solve equations by taking square roots. The equations that you can't solve by factoring, you can't solve by taking square roots, you can solve all of them using the quadratic formula. Does that make sense? So that's kind of comprehensive. Okay? All right, so with that preamble to the lesson, let's go into it. So we are going to use quadratic equations, the quadratic formula to solve equations. Now, your book actually derives the quadratic formula. I'm not going to derive the quadratic formula for you now. I will simply give it to you. But I will give it to you in the form of song. So what are we learning today? We are learning the quadratic formula.
Song.
Sure. We're learning the quadratic formula, and this is what it is. Are you guys listening? Okay, ready? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Awesome. Good. Clearly, quite a few of you know that already. It's very good. Praise God. Now, I'm going to sing it one more time so you can get the melody and the pitch. You know, it's very important here. You know, and then we're going to sing it together. Okay? So you're going to summon your inner Whitney Houston, your inner. Who's another one? I keep saying Miley Cyrus, but I just who's the guy? Enrique Iglesias. For those of you, summon your inner Enrique. Enrique. Come on.
That's the guy.
Maybe some J-Lo. I don't know. You guys don't even know who J-Lo is.
Too far.
Do you do? Beyonce?
Too far.
Okay. I'm just saying, if you're feeling Beyonce-ish right now, you can go for it. All right. I'll sing one more time. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Good, so you join me anyway. So now we're all going to sing it. All right, we're all going to sing it now. Ready? Okay. I want to hear everyone. Yes, even you, Caitlin. Okay, ready? Caitlin. All right, 3, 2, 1. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Good job. Good job, Paul. Good job. So that's the quadratic formula. And that's great. And clearly we're solving for x because x equals something. But when do we use it? Well, we specifically use it in the circumstance where we have a quadratic equation written in standard form, ax squared plus bx plus c equals 0. Okay, why? Well, if it's not in standard form, then we don't have an a, a b, and a c, so we can't plug it in here, right? And if it's not equal to 0, then it's not an equation. I don't have anything to solve for. Does that make sense? So this beautiful Beyonce-ish, I think I just coined a new, what's that, an adjective, right? Or is that, adverb? Beyonce-ly? I don't know. Like, I'm singing Beyonce-ly. That's, sorry. Okay, I took it too far. So this is our quadratic formula, and this is when we use it, when we have ax squared plus bx plus c equals 0. Is that clear? Okay, so you had your bell ringer. But let's use that as an example. We have x squared minus 4x plus 3 equals 0. So the first thing to do in this case is determine a, b, and c. So a is 1, b is negative 4, and c is 3. A is 1, b is negative 4, and c is 3. And then I just plug it in to my beautiful quadratic formula. So x equals negative b, so negative negative 4. Plugging that in, plus or minus square root negative 4 squared. And this will always be positive. Why? Because no matter what, if a number is negative or positive, the square of that number will always be positive. Minus 4ac 1, 3, all over 2a. So 2 times 1. And then I simplify. Negative negative 4 is positive 4, plus or minus square root. Negative 4 squared is 16, minus 4 times 3 is 12. All over 2a, which is 2. Okay, simplifying, I get 4 plus or minus square root of 16 minus 12 is 4. All over 2. Further simplifying, 4 plus or minus square root of 4 is 2, all over 2. Now, because that number underneath the square root, the number inside the radical is a perfect square, I ended up with the whole number here. That won't always be the case. But in this case it is. And when it is the case, once you get there, you separate to the two solutions, which are 4 minus 2 over 2 and 4 plus 2 over 2. Do you guys all understand that? Okay. 4 minus 2 is 2, divided by 2 is 1. 4 plus 2 is 6, divided by 2 is 3. So x equals 1 and 3. And if you did the bell ringer, you would have seen that those are the solutions by factoring as well. Okay? So this one you could have factored, but you can also use the quadratic formula. Okay, does that make sense to you guys? Okay, any questions on that? Okay. All right. Now, what I'd like to focus on now, well, first let me write it again. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Yeah. All right. Once I've written that down, I'd like us to focus on this thing here that I'm circling many, many times. Okay? This is called the discriminant. The discriminant is b squared minus 4ac. Got it? The discriminant is b squared minus 4ac. It's the part of the quadratic formula that's under the radical. See that? The part of the quadratic formula that's in the radical there, b squared minus 4ac, is called the discriminant. Now, we know its name, but what does it tell us? Well, in order to understand that, I'd like us to go through this. Plus or minus square root of 4. How many numbers is that? How many solutions is that? 2, right? Well, what's the square root of 4? 2. So this is negative 2 and positive 2. Is that right? So there are 2 possibilities for plus or minus square root of 4, right? Does that make sense? Well, what about plus or minus square root of 0? How many possibilities are there for that? 1, right? Well, square root of 0 is just 0. Doesn't matter if it's positive or negative, it's still 0. So the only possibility for that is 0. So there's one solution there. What about if I give you plus or minus the square root of -4? And I tell you, give me all the real numbers that are represented by that. Well, are there any real numbers that you can multiply by itself to get -4? No. You can't take the square root of a negative number and get a real number. So there are no solutions. So there's none. So it's 2, 1, and no solutions, 0 solutions. Okay? If it's negative. Why did I just show you this? Why did we take the time? Well, take a look at the discriminant. I'm going to write it over again. X equals -b plus or minus square root b squared minus 4ac all over 2a. Well, take a look at this. Let's say the discriminant is positive. Okay? If the discriminant is positive, it doesn't matter what this or this are. I'm going to have plus or minus some positive number, so x can have how many solutions? 2 solutions. Does that make sense? Because there's a positive and a negative of that radical. Does that make sense? There's a positive and negative, so there's 2 solutions. X can have 2 solutions. That equation has 2 solutions. What about if the discriminant is 0? If this is 0, do I even care about that term? No, it's just 0. So what's the solution? It's -b over 2a. It doesn't matter. If this is 0, that whole term cancels out. Do you guys see that? Does that make sense? That whole term just cancels out if it's 0, right? So how many solutions do I have? 1. If the discriminant is 0, then that equation has 1 solution. And if the discriminant is negative, well then I'm doing plus or minus the square root of a negative number. But are there any real solutions to that? No. If the discriminant is negative, there are no real solutions to that equation. Does that make sense? So what is it that I'm telling you? Well, with the discriminant, we can determine the number of solutions of our quadratic equation. If the discriminant is positive, we have 2 solutions. If the discriminant is 0, we have 1 solution. And if the discriminant is negative, we have no solutions. Does that make sense? Does that make sense, you guys? Questions? Yes, sir.
Will it ever be more than 2 solutions or no?
No, just like a quadratic. Remember a parabola? Remember, the zeros of a function are where the function is equal to 0. Well, remember here, in order to use the quadratic formula, I have to have some quadratic function, ax squared plus bx plus c equal to 0, right? So if I'm solving for that equation, I'm finding the zeros of the related function. You guys remember that lesson? Finding the zeros of the related function. Well, how many zeros can a parabola have? How many times can it cross the x-axis at most?
Twice.
Just twice. So there can only be a maximum of 2 solutions. Does that make sense to you guys? Okay, so let me make it very clear. Okay, the discriminant is b squared minus 4ac. And if that discriminant, b squared minus 4ac, is greater than 0, there are 2 solutions. If b squared minus 4ac, the discriminant, is equal to 0, there's 1 solution. And if b squared minus 4ac is less than 0, there are no solutions. So the quadratic equation. Does that make sense to you guys? Is that clear? Okay. So what does this look like? Any questions on that, guys? Okay, what does this look like graphically? Well, we have our good friend Desmos here. And if we take a look, we see here this dot here is telling us what our discriminant is. So it says our discriminant is positive there. Well, our discriminant is positive. If our discriminant, so the way that this graph works is it tells us what the discriminant is based on the function that's plotted. Does that make sense to you guys? So the discriminant is positive here. How many zeros does this function have? 2. It's got 2 zeros. Well, there you go. The discriminant is positive. I got 2 solutions. Does that make sense? And then look. right here. It says the discriminant is 0. How many solutions does the function have? How many zeros? 1, 0. And then, bam. Now the discriminant is negative. How many zeros does it have? None. There are no solutions. Does that make sense to you guys? So you can see, look, it's only at this one spot that the discriminant is 0. You see, there's only one solution. And then the discriminant is positive for all these ones. And then just that one spot, bam, discriminant is 0. And then discriminant is negative. You guys see that? Does that make sense to you guys? You understand? So discriminant is positive, 2 zeros. Discriminant is 0, 1 solution. And if discriminant is less than 0, it's no solutions. Does that make sense to you guys? I hope so. Any questions? No. All right. Let's go ahead and do that for this one. So this was the example that we used before. You guys remember that? X squared minus 4x plus 3. What's the quadratic formula? X equals negative b plus or minus square root b squared minus 4ac all over 2a. Well, in this case, we know a is equal to 1, b is equal to negative 4, and c is equal to 3. And thus, our discriminant, we remember, is b squared minus 4ac. So if I'm trying to determine how many solutions I have to this, I don't have to do the whole quadratic formula. I just have to find the discriminant. Is this any questions on this, guys? The discriminant is how we find the number of solutions. Okay? So we get negative 4 squared minus 4 times 1 times 3. Negative 4 squared is 16. Minus 4 times 3 is 12. 16 minus 12 is 4. Class, is that positive, 0, or negative? What do you guys say? Positive? Positive? Raise your hand if you think that's positive. Raise your hand if you think positive 4 is a positive number. Ah, you guys are alive. Nice. With vigor and enthusiasm. Right? Okay. Raise your hand if you think it's a negative number. Just kidding. Don't. Okay. Yes, this is a positive number. So how many solutions does it have? 2 solutions. The discriminant is positive, so it has 2 solutions, and that's exactly what we found. Our solutions, remember, were x equals 1 and x equals 3. You guys remember that? Okay. All right, so go ahead and do this on your own. Now, you're going to use this exact method to find the discriminant for numbers 3, 4, and 5. Okay? So on page 383, numbers 3, 4, and 5. You're finding the discriminant using the exact same method for questions number 3, 4, and 5. So you already have what the discriminant is, b squared minus 4ac. So honestly, all you have to do is determine what a, b, and c are, and then just plug them in there. 15 seconds. All right. And keep working for just another second. Okay. First thing I do is find A, B, and C. So I'm going to do that for all of them. Honestly, you may not think it's necessary, but I highly recommend you actually write out A equals this, B equals this, and C equals this anytime you use anything with the quadratic formula. And we have to remember that the discriminant is b squared minus 4ac. That song really helps. There's a reason why I have you guys do the song. It just becomes like a memory thing. Instead of like having to access your memory, like your visual memory, it's an auditory memory. And a lot of you guys are more able to pick up auditory information and remember it. And obviously it's going to be stored in your visual memory anyway because you're writing it so many times. Does that make sense? So singing that song increases those memory triggers, which will help you to just memorize that formula quickly. Okay, so just plug it in there. 4 squared minus 4 times 1 times 1. 4 squared is 16, minus 4 times 1 is just 4, so this is 12. This is a positive number. How many solutions does it have? 2. Okay. This one I've got negative 6 squared minus 4 times a is 2 times c is 15. Negative 6 squared is 36. Minus 4 times 2 is 8. 8 times 15 is 120. 36 minus 120 is negative 84. How many solutions does this have? None. No solutions. Does that make sense? Okay. Now this one, it's 6 squared minus 4 times 1 times 9. 6 squared is 36. Minus 4 times 9 is 36. 36 minus 36 is 0. How many solutions does this have? 1. One solution. Any questions on that? Okay, so you now know how to use the discriminant to determine how many solutions there are of a quadratic equation. Good. Any questions on how I did this? Okay, cool. Coolio. All right. Now, quadratic formula. Now, when you end up with the discriminant being a perfect square, then the discriminant is the number inside of that radical, right? So when it's a perfect square, using the quadratic formula is quite simple. Why? Well, because you just plug the numbers in, you simplify, you end up with the square root of a perfect square, which is just going to end up as a whole number, and then you simplify the same way we did. You end up here with negative 3 plus or minus 7 over 4. Let's negative 3 plus 7 over 4 and negative 3 minus 7 over 4. You simplify, negative 3 plus 7 is 4 over 4 is 1. Negative 3 minus 7 is negative 10 over 4, which is negative 5 over 2. Does that make sense to you guys? Okay, so look, when the discriminant is a perfect square, it's arbitrarily simple. The only danger there is making a mistake in your algebraic simplification. Okay? If you're struggling with your algebra and your simplification, then yes, that will be challenging to you. But you got to brush up on those skills in order to do this, because realistically, all you're doing is remembering this, figuring out A, B, and C, plugging in, and simplifying. Okay? And when it's a perfect square, that's pretty simple, because you don't have to do anything with radicals. But where it becomes challenging is where it is not a perfect square. So let's give an example of that. So if you go down to your next page, 384, we see this one here. And we can notice that one side isn't equal to 0, but in order to use my quadratic formula, I have to have one side equal to 0. So that's what I start with. I start with subtracting 2x from both sides. And I end up with x squared minus 2x minus 4 equals 0. Okay. Christiana, what is A in this case?
1.
1. Good. Alicia, what's B? Is it positive 2 or negative 2? Good. Summer, what's C? Negative 4. Good. A is 1, B is negative 2, C is negative 4. All right. Now, I have to remember my quadratic formula. X equals negative b plus or minus square root b squared minus 4ac all over 2a. Okay, and then I just go ahead and plug that in. X equals negative b, so it's negative 2, plus or minus square root b squared is negative 2 squared minus 4 times a is 1 times c is negative 4 all over 2 times 1. Is everybody clear on how I'm doing that? Yeah? Any questions? Look, you might notice that I put everything in parentheses. I highly recommend you do that. You may be tempted to just do like, oh, 2 times a. Well, I know it's just 1, so that's just 2. You may be tempted to do that, but I recommend that you don't. Why? Because it might be easy sometimes. Sometimes it will be more challenging. And if you don't put yourself in the habit of taking that time to do the extra step now, you'll be less likely to do it when you really need to do it. So we start off there. Negative 2 is positive 2, plus or minus square root of negative 2 squared is 4. Minus 4 times 1 is negative 4. Negative 4 times negative 4 is positive 16. All over 2 times 1, which is 2. Okay, so I just simplified, and I moved it forward one step. Then I go ahead and do the same thing again. Simplify plus or minus the square root of 4 plus 16 is 20, all over 2. Okay. Now, before I go on, let me stop there. The first mistake that I generally see, there are 3 mistakes that I will go into in this one problem that I generally see when people use quadratic formula. The first mistake is with signs. Either you miss a negative somewhere, or you multiply a negative times a negative and you keep it as a negative, or something. The first mistake I generally see is in signs. There's some error in the signs. You make one thing negative when it should be positive, or vice versa. So that's the first mistake. The second mistake is what is in doing what we're going to do right now. We see we have 20 as my determinant. That's good because I know I have a real solution. And the determinant's positive, so I know I have 2 solutions. But is 20 a perfect square? No. I don't know the square root of 20 offhand. So since that's not a perfect square, I can't just say, oh, square root of 25 is 5. Well, square root of 25 is 5. I know that, but I don't know the square root of 20. So I got to do something else with it. And what I have to try to do with it is simplify it. Okay? And in order to simplify this, I have to ask myself, are there any perfect squares that factor into 20? 4. Right? And so if you guys remember the product property of radicals, square root of 20 equals the square root of 4 times 5. And why did I do that? Well, then I could use the product property to separate that as square root of 4 times square root of 5. And then I end up with, what's the square root of 4? 2. Do I know the square root of 5? No, so I leave it like that. Okay, I take that number and I plug it back in here. I get 2 plus or minus 2 radical 5 over 2. Does that make sense? Yeah? Now, look. That's where I usually see the second mistake. I usually see the second mistake here. Or the second mistake I usually see is here. Simplifying the radical improperly. Okay? So we have to be aware of this. But what are we doing? All we're doing is factoring out a perfect square and then separating the two radicals. Okay? All right. So that's usually where I see the second mistake. And now is where I see the third mistake, usually. And this is one that it's like, because you're so close to the answer. It's like, any track people in here? I know I've asked that many times before. No track people. No track, cross country. Yeah, you are, right? You run track? Yeah. So, like, which ones do you run? The 100 and 200. Okay. Imagine you're running the 200 and you're, like, blasting past everyone. Like, you know, there's The Flash on Netflix. You're like The Flash, and the other people are, like, not even, like, awake out of bed yet, right? You're just like, bam. They're, like, still on the starting blocks, and you are right there at, you know, like, right near the finish line, right? Without a false start, no. You're right there at the finish line, and then it's like, bam, you stumble right at the very end, and they just, like, walk past you, and they're like, sweet, we won, right? You're like, no, right? Okay, so is that a clear picture? So that's what happens here. Because you've gotten so close to the finish line, but I so often see people do this. And so I don't want you to make this mistake. That's why I'm showing it to you. So often I'll see people do this. Okay, the 2 and the 2, they cancel, and this is just plus or minus 2 radical 5 or something like that. But you can't do it like that. Look, how many terms are in the top here? 2, right? How many of them are over 2? All of them, right? So how many of these terms should you divide by 2? All of them, right? They're all divided by 2. Divide them all by 2. Okay? So let's go ahead and do that. We get x equals, what's 2 divided by 2? 1. Plus or minus 2 radical 5 over 2 is? It's just radical 5. If you can't see that, look. 2 radical 5 over 2, they just cancel out, right? So I end up with 1 plus or minus radical 5, which I break apart to 1 minus radical 5, and x equals 1 plus radical 5. Does that make sense to you guys? You guys understand that? Do you see the process? You see what we did? Yes, sir. Which other 2? Right. So both of these terms, class, now listen. Both of these terms, I have to divide by 2. You go ahead, sorry. The 2 divided by 2 is 1. The 2 radical 5 term divided by 2 is just radical 5. So I have to divide both of them by 2. Any other questions? All right. So, good. Now, homework. What is your homework? Oh, wait. Should I make you do that? No. Homework. No homework. It's a Wednesday. It's Tuesday. You almost got me. Except I'm like ruthless about that. Like I'm the one, I support so much not having too much homework. And I clearly like just give it anyway. No. Never mind. It's too long. 389, numbers 1 through 14. 1 through 14? Negative b squared minus 4ac. What? Yeah. Let's skip lesson 2. That's what I explained at the beginning of class. Nice, guys. All right, now, shh. Look, just making sure that we're on the same page, right? Okay. All right, shh. Number 6. Look, I'm going to do this one for you. So pay attention. Pay attention to me, okay? Now listen, everybody, okay? Look it up right here. Okay, shh. All right. Numbers 1 through 8 just ask you to find the discriminant. Do not make the mistake of solving for x in all those. They're just asking you to find the discriminant. Okay? So what is the discriminant? The discriminant is b squared minus 4ac. So you just have to find the discriminant and use that discriminant to figure out the number of solutions. Well, the first step here, this is number 6 in your homework, is determining a, b, and c. Well, a is 1/4, b is negative radical 7, and c is 7. Okay? Don't be confused by the fact that the number is after the x. Okay? It's still negative radical 7 multiplied by that x. All right? Then I just plug in b, a, and c into the discriminant. I get negative radical 7 squared minus 4 times 1/4 times 7. So that's just plugging a, b, and c into that formula. Now, when I square a negative number, it becomes a what, class? Positive. When I square a square root, what happens to them? They cancel, right? So it all cancels. This just becomes 7 minus, what's 4 times 1/4? 1. Yeah. 1 times 7 is 7. 7 minus 7 is 0. So the discriminant is 0. How many solutions do I have? One solution. All right. Got it? All right. Good job, class. All right. So that's it. That's it for the day. That's the lesson. Go ahead and start your homework.